Let us solve the following system of linear inequalities. So we'll begin with the first one. So we have x divided by 2x plus 1. So this is greater than or equals to 1 over 4. We'll transpose 1 over 4 from the right hand side to the left hand side to get x divided by 2x plus 1. So this is minus 1 over 4 greater than or equals to 0. Combining the two terms, so we have a common denominator 4 times 2x plus 1. And in the numerator, we have 4 times x minus 2x minus 1. So this is greater than or equals to 0. So 4x minus 2x, that gives us 2x. So we have 2x minus 1 divided by 4 times 2x plus 1. Right. This is greater than or equals to 0. We'll take 2 as the common factor in the numerator. So we have 2 times x minus 1 over 2. And we also take 2 as the common factor from 2x plus 1. So that gives us, we already have 4. So 4 times 2 will get 8. So we have x plus 1 over 2 greater than or equals to 0. So that means we have 1 over 4 multiplied to x minus 0.5 divided by x plus 0.5. So this is greater than or equals to 0. What we'll do? We will get rid of this 4 from both sides by multiplying 4 to each of the sides. But before doing that, we'll have to use a property of inequality. That means, let's say we have two numbers a and b, and a is greater than or equals to b. And we have another number c, and c is a positive number that is greater than 0. Then if we multiply a with c and b with c, then ac will be greater than or equals to bc. That means the sign of the inequality is not going to change. So here what we'll do, we'll multiply both sides with 4, and this is not going to affect the sign of the inequality. So this is going to give us x minus, let me write it here. So this is going to give us x minus 0.5 divided by x plus 0.5. So this is going to be greater than or equals to 0. So let's label this as number 1. Now we have to find a solution to this linear inequality before moving on to the second linear inequality. So let's start with this one. Now this one is going to give us two cases first. We'll have case number 1. In case number 1, we are going to consider both the numerator and the denominator to be positive. So here the numerator x minus 0.5 is greater than or equals to 0, and the denominator is x plus 0.5. So this is going to be only greater than 0. It cannot be equals to 0 because we'll have a division by 0, which is not allowed. So let's solve them. So this gives us x greater than or equals to 0.5 and x greater than negative 0.5. To find the solution, what we'll do, we'll consider a number line. So on the number line, we will consider x equals to negative 0.5 and x equals to positive 0.5. So here we'll have to consider for the first inequality, x is greater than or equals to 0.5. That means all the values of x. So this is all the values of x, which starts at x equals to 0.5 and goes all the way up to positive infinity. So this is positive infinity. So that means it's lying to the right of 0.5, including 0.5. And x greater than negative 0.5 means all the values of x which is greater than negative 0.5, that means lying to the right of negative 0.5 and extending all the way up to positive infinity. And we have used a bubble here, which means that negative 0.5 is not a part of the solution, whereas I have used a dot here, which means that 0.5 is a part of the solution. Now we have to find a common region. In the common region means a value of x which is going to satisfy both of the two linear inequality. So this is the common region. So this common region is nothing but x greater than or equals to 0.5. Right. So this is what we have obtained from case number 1. Now we'll go to case number 2. What we'll do in case number 2, we will consider the numerator, which is x minus 0.5, to be a negative number. That means less than or equals to 0, and simultaneously we'll consider the denominator, which is x plus 0.5, to be a negative number as well. So that means we have a negative number divided by another negative number, which makes it positive, and our inequality will be greater than 0. Fine. So let's solve them. So we have x less than or equals to positive 0.5 and x is less than negative 0.5. So we'll have to find a common solution to both the two inequality. So we'll have a number line. On the number line, we'll consider x equals to negative 0.5 and x equals to positive 0.5. Fine. So x less than or equals to positive 0.5 means we'll consider all the values of x which is less than 0.5. That means it's going to lie to the left of positive 0.5 and extending all the way up to negative infinity, and it's also going to include 0.5. So that's why I've used a dot here. And x is less than negative 0.5 means all the values of x lying to the left of negative 0.5 and extending all the way up to negative infinity, and bubble means it's not a part of the solution. So our common region will be this particular region, and this is nothing but x less than negative 0.5. So I have used a less than sign here because negative 0.5 is not a part of the solution. So that means from our case 1 and 2, we can say that our solution to our particular linear inequality number 1, so that will be given by x greater than or equals to 0.5 or x less than 0 minus 0.5. That means if we want to write the solution set, all we have to do is first sketch the number line. So here we have the number line. On the number line, we'll take negative 0.5 and x equals to positive 0.5. So we have obtained the solution that x is greater than or equals to 0.5. So this is the region, x greater than 0.5 and x less than minus 0.5, which is this is the region. So our solution will be negative infinity to negative 0.5. So negative 0.5 is not a part of the solution, so we'll use an open interval, and infinity is always unbounded. Union, we have 0.5 going all the way up to positive infinity. So 0.5 is a part of the solution. Here I've used the closed interval, and infinity by definition is unbounded, so this is an open interval. So this is a solution to our first linear inequality. Now we'll have to move on to the second linear inequality. So let's solve the second linear inequality. Now let's solve the second linear inequality. We'll begin by transposing half to the left hand side. So here we have 6x divided by 4x minus 1 minus half less than 0. Combining the two terms, we have a common denominator of 2 multiplied to 4x minus 1, and in the numerator we have 12x minus 4x plus 1. So this is less than 0. The 12x minus 4x gives us 8x. So we have 8x plus 1 divided by 2 times 4x minus 1 less than 0. In the numerator, we'll take 8 as the common factor. So we have 8 multiplied to x plus 1 over 8 divided by, so here we have 4x minus 1, we'll take 4 as the common factor, and that gets multiplied to 2 to give us 8. So we have 8 multiplied to x minus 1 over 4. So this is less than 0. The 8 and 8 gets cancelled out, and that leaves us with x plus 1 over 8 divided by x minus 1 over 4. So this is less than 0. In order to solve this linear inequality, we'll have to consider two cases. So let's start with case number 1. So in first case, we'll consider the numerator to be a positive number and simultaneously the denominator to be a negative number. Then that means we have a positive number divided by a negative number, so that becomes negative, which satisfies the inequality, which is less than 0. So we get x greater than negative 1 over 8 and x less than 1 over 4. On the number line, we'll sketch it. So we'll have negative 1 over 8 and positive 1 over 4. So x greater than negative 1 over 8 means all the values of x which is greater than negative 1 over 8 lying to the right of negative 1 over 8 and extending all the way up to positive infinity, and x less than 1 over 4 means all values of x which is less than 1 over 4, and meaning all the values of x that is less than lying to the left of 1 over 4 and extending all the way up to negative infinity. So this is going to be the common region which satisfies both the two inequality. So here we have negative 1 over 8 going all the way up to 1 over 4, and this is going to be an open interval because the endpoints are not part of the solution. So this is what we obtained from case number 1. Now let's look at case number 2. So in case number 2, we'll consider the numerator, which is x plus 1 over 8, to be less than 0, a negative number, and the denominator, which is x minus 1 over 4, to be a positive number. So now we have a negative number divided by a positive number, which is again negative, and it's going to satisfy our linear inequality. Right, so let's solve this. Well, we have x less than negative 1 over 8 and x greater than 1 over 4. On a number line, we'll have x equals to negative 1 over 8 and x equals to positive 1 over 4. So we have x less than negative 1 over 8, which simply means we have to consider all the values of x lying to the left of negative 1 over 8, and x greater than 1 over 4 means all the values of x lying to the right of 1 over 4. So clearly we do not see any intersection between the solutions, so we'll have no solution. There is no solution to this linear inequality. That means to this particular case, only case number 1 gives us a solution which is negative 1 over 8 to 1 over 4. So now we have obtained a solution to both of the two linear inequalities. So let's combine them. So our first linear inequality gave us the solution negative infinity to negative 0.5 union 0.5 to infinity, and the second linear inequality gave us negative 1 over 8 going to 1 over 4. Right. So let's try to combine these two solutions on a number line. So we will combine them graphically. That's going to help us easily find out the common solution. So we will plot the point negative half, negative 1 over 8, 0. Then we have 1 over 4 and 1 over 2. From the first set of solution, we have going from negative infinity to negative 0.5, and we have union from positive 0.5 to infinity. The second solution is giving us a solution between negative 1 over 8 and negative 1 over 4. Now clearly from this diagram we see that there is no intersection between the solution. So here we will say that there is no common solution that satisfies both of the two linear inequality. So there is no solution to this system of linear inequality.